Now let's try a question from that. Okay, this one. 9 marks question. Interesting one. Try to break down the question in as many parts as you want and do it neatly, tidily, and then you can connect all of the things together. Because you can see you may need to apply physical stamina, you may need to apply kinematics, you may need to apply the friction thing, you may need to solve for the vertical components or the horizontal components. So there are a lot of things that you find separately and then you combine everything at the end. So when whatever the step that you are doing, be aware of it, and then okay, make separate sections properly, understand the question, and then you'll get your answer hopefully. So they have given us that the parcel is of mass 20 kg. So the weight would be downwards 20 g, is at rest right now. Okay, the velocity initially is 0 on a rough horizontal flow. Rough means, I told you, whenever it is written rough, then the friction is over there. So the coefficient of friction is given to us. Look, it is 0.3. Between the parcel and the floor is 0.3. Two forces both acting in the same vertical plane of magnitudes 200 Newton and 80 Newton. We can see both of them. And the directions are also given to us. Okay. The particle is modeled as sorry, the parcel is modeled as a particle P. Find the smallest value of T for which the P remains in equilibrium. Okay, this is an interesting one. Find the smallest value of T for which T remains in equilibrium. It remains in equilibrium means definitely this is limiting equilibrium, because the forces are being applied over here, but still there is friction as well, but still the things are not moving. It is still in equilibrium. And why are they telling to you that they find the smallest value of T? Because it is possible that this T value is so much larger that this is causing the limiting equilibrium to be rightward. So the friction would be on the left side. Or the T value can be as small, it can be more smaller than this one, has lesser effect than this 200 Newton, in such a way that in that case that the parcel is just on the verge of moving on the left side. So in this case, the friction would be on the right side. Okay, so there are two conditions that can be deduced out of this one. If your T is very large, definitely the parcel will be trying to move to the right side. So if it is on the verge of moving to the right side, then the friction would be on the left side. And if your T is small, this means that the 200 Newton is more effective in this case. So the object is on the verge of moving to the left. And if the object is moving to the left, then the friction would be on, in that case, applied to the right side. Do you get this or not? Any questions over here?
No, sir.
You don't get it?
No, I got it.
Okay. Nadia, Nuba, Nadia,
Yes, I got
especially you.
it.
Okay, so that's why they talked about the smallest value, because there were two situations that can be modeled out of this thing. So we have to separately solve, and then definitely, if you think about it, which situation would give you the smaller value of T? The situation in which this 200 Newton is more effective than the when the particle is just on the verge of moving on the left side. Because if we keep it this way, this means that this force is greater and this is smaller. The effect of this is smaller, and friction is also trying to oppose this one. So this is what my logic is telling me. Because if you want the object to be moving just on the verge of the right side, then this should be so large, then it should if cancel the effect of this 200 Newton cos component as well as the friction force. Do you get it? Do you get this thing or not?
Yes.
Yes, sir.
Okay, good. Finally. Okay, so now we can start with this situation. So this is on the verge of moving left. So frictional force you applied on the right side, F max. Now for F max we need mu r. Mu is 0.3 and we need n. N is the normal contact force, which would be upwards. which we would need to find out. And for that thing, we have to break it down. This would be t cos 25, and this would be t sine 25. This would be 200 cos 15, and this would be 200 sine 15. Okay, so if you equate the vertical components, that then vertically upwards you have n, vertically upwards you have t sine 25 as well, vertically upwards you have 200 sine 15 as well, and downwards you just have 20g. So 20 times 10 would be 200. Okay, 20g. So if you find your n, it is coming out in terms of t. So 200 minus 200 sine 15. This is 148.24 minus t sine 25 is 0.4. Let's keep it sine 25. Okay, this becomes your n. So the friction would be 0.3 times 148.24 minus t sine 25. Okay, now you form the equation for F is equals to ma. But not F is equals to ma, because acceleration is, we know it is in limit equilibrium, so this would be 0. So the forces on the left side are equaling out the force on the right side. So on the left side you have 200 cos 15, nothing more. This is equals to t cos 25 and the friction force F max. And F max we have already found, which is 0.3 times 148.24 minus t sine 25. So we have to find the value of t now. This is the equation that we've gotten. So t cos 25 and minus 0.3 sine 25, isn't it? So you are getting t 0.77952 and 200 cos 15 minus 0.3 times 148.24. So you're getting 148.7, 148.713. So t comes out as this answer divided by 0.77952, which is 190.78. And correct to 3 significant figure, 191 Newton. Okay, do you get it? Any questions? Nadia, all good?
Yeah, sir, it's fine.
Difficult or easy?
It's okay.
It's okay. Not easy, not difficult. Okay, it's interesting. I like questions like these. When you have a lot of information and you have to assess what should be used where, and once you get the right answer, then it gives you a lot of satisfaction. Then you try to enjoy it. Let's confirm. Let's confirm if our answer is correct. This is January 2021. January 2021 MS. Which question was it? Question number 3. Bismillah. 191, 190 or 192? What did we get? 191. I think we made some. If we would have taken, sorry, what do we say those? The exact values, then you would have gotten a better answer. So it's correct, 192.31. Okay.
Yes, sir.
It's just the, I think, error of accuracy. Otherwise, if we would have got kept it in the exact forms, the exact values, then we would have got a much better, closer answer. But the information, how you work with the things, how you understand the question, that was important. And this was a difficult question, Nadia. This was not an easy one, not a medium one, because this thing, the main thing which I explained to you, you have to assess this thing yourself as well. Okay, you have to use logical reasoning behind whatever the thing that you're using, because I kept this situation in my mind, and then I thought, why are they talking about these two values of t, smallest value of t? This means that there's another value of t that is also possible, not just one value of t. So which one, how, which situation would give me the smallest value of t, where, why? So that's why this was a good one. Okay. The 9709, we have questions like these. Okay, so this was a very good example for you people as well. In past papers, this is one of the difficult questions. Otherwise, the questions are very straightforward. Okay,